Now let us discuss one more problem in trigonometric Fourier series, and then we'll move on to the second form of Fourier series. So this is the last problem that we'll discuss for trigonometric Fourier series. If you look at this signal, if I draw the folded version of this signal when folded, how will it look? It will look something like this, right? It will look something like this. So it is not an even signal, and it is not an odd signal also, and it does not exhibit any symmetry. This signal is a signal which does not exhibit any kind of symmetry. It is not even, it is not odd, and it is not half-wave symmetric. So for this we have to find all the three parameters, A0, AN, and BN. All three we have to calculate. So let us calculate A0. Let us calculate A0. A0 is equal to 1 by t, 0 to t, x of t dt, right? So that is, what is x of t here? It is a ramp function. What is this point? This point is t comma a. It is t comma a, and this is 0 comma 0, right? So I need to find the expression for x of t using the 2-point form, right? What will be the x of t? My formula will be y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. So y here is x of t. X of t minus y1 is 0, so that is equal to y2, that is a minus 0, that is a, by x2 minus x1, t minus 0, that is t, into x minus x1. X is equal to t minus x1 is 0. So this is my expression for x of t from 0 to t, right? So in place of x of t, I can write a t by t. So let me substitute. A by t is constant, so I can get it outside. A by t, we already have a t here, so a by t square, right? And then 0 to capital T, t dt, t dt. Now let me integrate. Integration of t dt. What is it? It is nothing but t square by 2. T square by 2. My limits are 0 to t. When I substitute the limits, I'll get a by t square into t square by 2, right? T square by 2. T square gets cancelled, and I have a0 is equal to a by 2. A0 is a by 2. Then I'll calculate an. Then I'll calculate an. The formula for an is 2 by t integral 0 to t x of t cos n omega naught t dt, right? That is equal to, again, in place of x of t, at by t. So 2a by capital T integral 0 to t t into cos n omega naught t dt, t into cos n omega naught t into dt. That is, now we have to integrate this. We have to solve this integral. So this is in the, we can write it as, we can take it as u dv, right? We know integral u dv is equals to uv minus integral v du. So here u is t, right? I'll take u is equals to t and v equals to cos n omega naught t, sorry, dv is equal to cos n omega naught t into dt. So what is du? Du is equals to dt and v equals to integral of cos. Integral of cos is sine, right? That's equal to sine n omega naught t divided by n omega naught. So substituting these values here, I'll get an is equals to 2a by t. Now uv, what is u? U is t and v is sine n omega naught t divided by n omega naught This has the limits 0 to capital T and minus integral 0 to capital T v du. V is sine n omega naught t by n omega naught into dt. Du is dt. Now let me just substitute this limits here. If I substitute, so this is all in the brackets, right? If I substitute t is equal to capital T, omega is 2 pi by t. 2 pi by t into t is nothing but 2 pi. Sine 2n pi is 0. Sine 2n pi is always 0, right? So here I have 2a by t. Sine 2n pi is 0, and if I substitute t is equal to 0, it is 0. So this whole thing reduces to 0. And what am I left with? I am left with integral of cos, right? Integral of sine. When I integrate sine, what will I get? Integral of sine is negative cos. So already I have a negative sign, so it is cos n omega naught t divided by n omega naught, and I already have another n omega naught, so n square omega naught square limits 0 to t, right? So if I put t here, again I have cos n 2 pi, cos n 2 pi. So 2a by t n square omega naught square. I have cos n n 2 pi, t n 2 pi by t. I'm left with 2 pi minus cos 0 is 1. Now cos n 2 pi, that is cos of even pi. So cos of even pi, what will happen? This is cos 0 even pi, and then odd pi, again even pi. It's always 1. So this is equal to 1. So 1 minus 1 is 0. So my an is equal to 0, right? An is equals to 0. Now let me find out the last one, that is bn. bn also the formula is 2 by t 0 to t 0 to t x of t into sine n omega naught t dt, n omega naught t dt. So let me substitute the values of x of t, that is 2a by, so there is t square all around here, there's t square all around here, but the final answer does not matter, it is 0. Okay, 2a by t square 0 to t, and I have t into sine n omega naught t dt. So that is equal to 2a by t square. Now this is my u, and this is my dv. Now accordingly I'll substitute, I'll use the formula integral u dv, right? So u, so I have u, that is t, v, integral of sine is minus cos, so minus cos n omega naught t by n omega naught, the limits are 0 to t, minus integral v du, that is again minus cos, so this becomes plus cos n omega naught t by n omega naught dt. The integrals are again 0 to t. That is equal to 2a by t square, 2a by t square. So I have to substitute t here, n omega naught t, n into 2 pi by t into t, so n into 2 pi. So cos n into 2 pi is cos n into 2 pi. What is it? That is cos of even pi. Cos of even pi is always 1, right? This becomes 1, and I have minus t here. right? In place of t I have to substitute t, so minus t by n omega naught plus, or sorry, minus, in place of t if I put 0, it is 0, right? Plus integral of cos is sine n omega naught t divided by n square omega naught square limits 0 to t. So that is equal to 2a by t square, 2a by t square. Omega naught is equal to 2 pi by t. So substitute that, I'll get minus t square by 2n pi minus t square by 2n pi plus sine 2 pi. So here omega naught is 2 pi by t and t cancel, right? So sine 2n pi is 0, right? Sine 2n pi is 0 and sine 0 is also 0. So this is 0. So 2 gets cancelled, t square gets cancelled. I am left with, what am I left with? I'm left with minus a by n pi, minus a by n pi. So this is my bn. This is my bn. So I'll just write the final. Trigonometric expression, trigonometric Fourier series. X of t is equals to, what is my a naught? A by 2, right? A naught is a by 2 plus summation n is equal to 1 to infinity. N is equal to 1 to infinity. An is 0, so I don't have to worry about an. Bn is minus a by n pi, minus a by n pi. What is my multiplicative factor here? Sine n omega naught t. So this is my trigonometric Fourier series expression. Let me expand it. A by 2 minus a by pi into, when n is equals to 1, it is sine omega naught t. When n is equals to 2, it is sine 2 omega naught t by 2, and so on and so on. This is my final expression. Right? That is the end of trigonometric Fourier series. There are many other problems. You can follow any of the textbooks that were prescribed for you, and you can find the trigonometric Fourier series. Then the next form of Fourier series is polar Fourier series or cosine Fourier series. Polar Fourier series or cosine Fourier series. This is nothing but a modified form of trigonometric Fourier series, right? So this was the expression for trigonometric Fourier series. Now here I am going to multiply with a factor of square root of an square plus bn square and divide with the same factor an square plus bn square here, right? I am going to multiply and divide. So what will happen? Now this part here, I am calling it as cos pi n, and this as sin pi n, right? Then what will be my tan n? tan n is nothing but sine by cos, right? So tan n is sine by cos. So sine by cos is nothing but bn by an, and phi n is nothing but tan inverse of bn by an. So this is my expression. F of t is equal to a naught plus summation n is equal to 1 to infinity. I have a multiplicative factor of square root of an square plus bn square, and cos n omega naught into cos pi n plus sin n omega naught into sin pi n. So this whole thing, cos a b cos a b cos a cos b plus sin a sin b is nothing but cos a minus b, right? Cos a minus b. I have gotten into that form. So basically what I have done, in the original Fourier trigonometric Fourier series, we had sine as well as cos. Now we only have cos. We have converted the sine into cos. So it is called cosine Fourier series. Now this is I'm saying I'm replacing a naught by d naught and this by dn, right? So my cosine Fourier series is given by f of t is equal to d naught plus summation n is equal to 1 to infinity dn cos n omega naught minus phi n, where phi n is nothing but tan inverse of bn by an, tan inverse of bn by an. This dn is nothing but coefficients of amplitude spectrum of f of t, amplitude spectrum of f of t. dn is the amplitude of spectral component of frequency n omega naught. At n omega naught, the amplitude of the spectral component is dn. At omega naught, we have d1. At 2 omega naught, we have d2, right? So that is how we have modified the trigonometric Fourier series into cosine Fourier series. It is very simple to find out the cosine Fourier series. The procedure is same as trigonometric Fourier series. We will find a naught, an, and bn, right? We'll find a naught, an, and bn. So let us say I have found out a naught, an, and bn. I am interested in finding out d naught, and dn, right? D naught is nothing but same as a naught, right? So there's no calculation there. So when it comes to dn, I have to calculate it in the form of square root of an square plus bn square, an square plus bn square. So how do I find out that? So let me have my an, sorry, has to be subscript. I'll take my an, right? I'll take my bn as the table, right? an, then bn for n is equals to 1, 2, and so on. Then I'll calculate dn. What is the formula for dn? dn is nothing but square root of an square plus bn square, right? I'll calculate dn. Then I have phi n, that also I have to calculate. So phi n is equals to tan inverse of bn by an, tan inverse of bn by an. So for every an and bn, every pair of an and bn, I have to calculate this table, right? I have to calculate this table. Finally, I'll substitute the values in this formula. This is nothing but my dn, right? So, and this is nothing but my d naught, right? This is how I will find out my cosine series. We are not going to do any problems on this. So the procedure is similar to TFS with this extra table. You have to do everything what you did for trigonometric Fourier series, and then you should not just stop there. You should calculate this table here and substitute the values in this equation, here, right? In this equation we have to substitute the values of d naught, dn, and phi n. Okay, then we'll move on to the next one. Next one is complex exponential Fourier series. So far we have seen trigonometric Fourier series and cosine Fourier series. Now it is complex exponential Fourier series. It's also called just exponential Fourier series. So what we had previously, the trigonometric Fourier series, right? The trigonometric Fourier series. Now let us derive this complex exponential Fourier series from trigonometric Fourier series. So what is the trigonometric Fourier series formula? f of t is equals to a naught plus summation n is equals to 1 to infinity an cos n omega naught t plus bn sin n omega naught t, right? This is the formula for trigonometric Fourier series. Now we know that e power j theta is equals to cos theta plus j sin theta, right? E power j theta, right? Or e power minus j theta is equals to cos theta minus j sin theta, right? So if you add these two, what will I get? I'll get cos theta is equals to e power j theta plus e power minus j theta divided by 2. Similarly, sin theta, I will have the formula of e power j theta minus e power minus j theta divided by 2j. So instead of theta, I have here n omega naught t. So let me just substitute these relations in this formula. So what will my f of t be equal to? F of t is equals to a naught plus summation n is equals to 1 to infinity, n is equals to 1 to infinity. In place of in place of cos n omega naught t, I can write e power j n omega naught t plus e power minus j n omega naught t divided by 2, right? And the same thing for bn. In place of sine, I can write e power j n omega naught t minus e power minus j n omega naught t divided by 2j. Right, this is my expression now. Now what will I do? I can separate the terms based on e power j n omega naught t and e power minus j n omega naught t. So I will write a naught plus summation n is equals to 1 to infinity e power j n omega naught t. Right, e power j n omega naught t. What is the common thing here? E power j n omega naught t. I can write it as an. Then here I have bn, right? There I have bn, and in the denominator I have j here. So an minus j bn by 2, right, into e power j n omega naught t plus here again for this e power minus j n omega naught t I have for e power minus j omega naught t I have an minus j in the denominator. When it comes to numerator it becomes plus jbn by 2, right, jbn by 2 into e power minus j n omega naught t, right. Now I will take this as f naught and this as f naught, and this will be my fn, and this is going to be my f minus n, right, f naught plus summation n is equals to 1 to infinity fn e power j n omega naught t plus f minus n e power minus j n omega naught t, right. So that means I can write it as, here I have f naught, here I'll get f1 to f infinity, and here with this one I'll get f minus 1 to f minus infinity. So what can I write when I combine everything, all these things? 0 is there, 1 to infinity is there in this term, and then minus 1 to minus infinity is also there in this term. So combining everything I can write for all n, right, from for n is equals to minus infinity to plus infinity f n e power j n omega naught t. If I expand this I'll get the same thing. When n is equal to 0 it is f naught e power 0 is 1. When n is positive it is fn e power j n omega naught t. When n is negative it is f minus n e power minus j n omega naught t. So this is my expression for complex exponential Fourier series. Now what is the formula for fn? Right, what is the formula for fn? Fn formula is given by 1 by t. Fn formula is nothing but 1 by t 0 to t, 1 by t 0 to t, f of t e power minus j n omega naught t dt. Right, that is my f n. Right, 1 by t 0 to t or over one time period f of t e power minus j n omega naught t dt. So I can find my complex exponential Fourier series coefficients from trigonometric coefficients also. How? F naught is equal to a naught, fn is equal to half into an minus jbn, f minus n is half into an plus jbn. That is what we have written here, right? This is complex exponential Fourier series from trigonometric Fourier series. The other way around also we can do. We can find trigonometric Fourier series from complex exponential Fourier series. Right? We know what is the formula for complex exponential Fourier series. This is the formula for complex exponential Fourier series. Now, if I expand it, it will be f of t is equal to f naught plus f1 e power j omega naught t, f2 e power e power j2 omega naught t, and so on. F minus 1 e power minus j omega naught t, f minus 2 e power minus j2 omega naught t, and so on. If I combine these two here, e power j omega naught t plus e power minus j omega naught t, what will happen? What will happen if I combine e power j omega naught t and e power minus j omega naught t? It will become cos omega naught t into 2, right? It will become cos omega naught t into 2. So continuing this thing, I can finally get my trigonometric Fourier series coefficients. The formulas will be a naught is equal to f naught, an will be fn plus f minus n, right? Fn plus f minus n, and bn is going to be j into fn minus f minus n, right? So we'll see a few problems on exponential Fourier series in the next video.